Bismillahirrahmanirrahim. I'm Hussnain Ali from Bagh School, Muridke, grade 13 chemistry teacher. This is a video that is related to question number 6 of the P4 given by the students in chemistry. Here in the question number 6, the examiner is asking chlorine gas and iron 2 ions react together in aqueous solution as follows. The equation is given chlorine as reacting with iron 2 positive ion to form chloride ion and iron 3 positive ions. Here the subpart A, the diagram below shows the apparatus needed to measure the E cell theta for the above reaction. This is the diagram which is labeled with different parts A, B, C, D and E. In the subpart of A, he was asking in the spaces below, identify what the 5 letters A to E in the above diagram represent. So if you would be going through your notes, you can see that when this type of delivery tube is shown, in the case of A, you can see this delivery tube, then some gas is being bubbled in the solution. So here for the A part sake, only gas that is reacting in this reaction is basically chlorine. So in the A part, basically chlorine is being bubbled in. While in the B part, he has labeled the B part. So basically this is the solution of the chlorine gas ions that is to be taken here. That is that either we take chloride ions or the solution of chloride ions in the form of NaCl or HCl solution. So for the C part sake, this is a U-tube type of tube that is being drawn here, that presents a salt bridge, and it contains potassium nitrate and potassium chloride. While for the sake of D part, this is an electrode that is represented here. Here, as you can see, that chlorine makes half cell to the left side, while the iron 2 positive and iron 3 positive ion solution forms the right side of the diagram. So basically, this type of a case is being discussed in the classes also. So for this type of a solution, we use inert electrode like platinum. So we will be using platinum here as an electrode, and the D part is representing the platinum electrode. While for the sake of E part, this is a solution of iron 2 positive and iron 3 positive ions at standard conditions, being that it contains 1 mole per dm cube, both ions concentration. The answers of whole of the parts are given at the bottom of the slide. You can see the answers and refer to them. While in the second part, the examiner was asking use the data booklet to calculate the E cell theta for this reaction and hence decide which direction electrons would flow through the voltmeter when the switch is closed. So we have to calculate the E cell theta for this reaction. So basically our left hand side is of chlorine and our right hand side is of iron 2 positive and iron 3 positive solution. You can go through your data booklet and see what are their electrode potentials. So for the calculation purpose, we would have to write E theta is equal to E right hand side minus E left hand side. That becomes equal to 0.77 minus 1.36, and the answer comes out to be minus 0.599. Here he has shown that ignore the sign at the bottom of the slide, because actually the electrode whose potential is high or more positive is written or is drawn on the right hand side. He has drawn the chlorine electrode on the left hand side. That's why he is ignoring this sign. Actually the answer should have been 1.36 minus 0.77 according to the rules and regulations of the drawn diagram. But here the diagram is drawn in opposite manner, so we have to calculate accordingly, but it doesn't matter here. So in which direction the current would flow? If you would go through your data booklet, you would see that for the chlorine electrode, the electrode potential is 1.36, while for the iron 2 positive, iron 3 positive ions half cell, the electrode potential is basically 0.77. So the reduction potential of the chlorine electrode is high as comparative to iron 3 positive half cell. So basically the electron would flow from the right hand side to the left hand side, from iron ion solution to the chloride ion solution, because the iron ion solution is basically acting as an anode, while the chloride ion solution electrode part is acting as a cathode. I have written the answers here. You can see that the electrode is negative on the right hand side, and the current will flow from the right to left, or the chlorine electrode towards the chlorine electrode, or anti-clockwise from beaker A to beaker B. In the B part, he was saying iron 3 chloride readily dissolves in water. So this is the equation that is written here. FeCl3 is being ionized in water to form iron 3 positive ion plus 3 chloride ions. In subpart 1, use the following data to calculate the standard enthalpy change for this process. The enthalpy of formations of iron chloride, iron 3 positive aqueous, iron chloride and aqueous is given. So basically you have to draw Hess's law diagram or Hess's cycle here, which would be in the shape that you have to write the iron plus chlorine in the elemental form at the bottom of the equation, and draw two arrows from that side to the iron side and to the salt side. When you would be drawing those two arrows, you are able to identify the direct path and indirect path, and with the help of that you can correlate the answer that I have written here, that the delta H for this reaction is calculated, and that comes out to be minus 150.6 or 151 kilojoule per mole. So basically this was done with the help of Hess's law cycle. You can draw on your own self. You can see how the enthalpy of formations Hess's cycle is drawn within your notes, and you can get the answers related to this part also. For the second part of B, he was asking a solution of iron 3 chloride is used to dissolve unwanted copper from the printed circuit boards. When a copper coated printed circuit board is immersed in iron 3 chloride solution, the solution turns pale blue. It means that basically copper that is in the elemental form is reacting, and it is forming copper 2 positive ions. So the reaction basically is between the iron 3 positive ions and copper 0 to convert iron 3 positive ions to iron 2 positive ions, while to convert copper 0 to copper 2 positive ion. He has asked just an equation for the reaction between the copper and iron 3 chloride, and use the data booklet to calculate the E theta for the cell. So I have written the answers at the bottom of the slide. You can see that the iron 3 positive ion in the iron chloride is basically reacting with copper, and it is forming iron 2 positive ions plus copper 2 positive ion. This is a set of equations that is formed with the help of two equations from the data booklet by using the equations of the reduction potential of iron 3 positive to iron 2 positive and copper 0 to copper 2 positive. A net equation then would be formed by the equivalence of the electrons, and the electrons are cancelled out to get the equation that is written as an answer for this part. For the calculation of E cell, by the rule, the electrode whose potential is high is taken as the E cathode, and the whose potential is low is taken as E anode. So here you have to minus the E cathode with E anode, or E right hand side minus E left hand side, because by rule we draw the higher reduction potential half cell on the right side, while the lower reduction potential half cell on the left side of the diagram. So the answer comes out to be E theta is equal to 0.77 minus 0.34, that is plus 0.43. Do take care while doing this part, because the reduction potential of the half cell that is high is written on the left side, while the reduction potential with the low the reduction potential of the half cell which is low is written on the right hand side. So E cathode minus E anode, or E right hand side minus E left hand side, gives plus 0.43. Here plus represent the overall answer that is to be given, not in the negative but in the positive sense if rightly calculated. So students, this was the video that was related to electrochemistry. Hopefully you are finding these videos useful for understanding the concepts. Take care. Allah Hafiz.